So let's do an example of an object that is launched horizontally, okay, and then we'll go to ones that are launched at different angles. Or actually a couple examples of ones that are launched horizontally. But again, we're going to just follow our basic steps, right? Step one, so here we go. We have an object launched horizontally with 30 meters per second from a 50-meter high cliff. Find its time to hit the ground, and then its range. Okay, so range, anytime you see it, is the horizontal displacement. Okay, so again, write your, follow the steps. Step one, break up that initial velocity vector into components. Well, the good thing about it, when it's launched horizontally, there's only one component. The other component is zero. Okay, so at 30 meters per second is in the x direction, and 0 meters per second in the y direction. Okay, now step two, right, is to write the position functions. And this is what I was telling you in that one video. If I just make a T chart, right, I've got a horizontal side and I have a vertical side. Okay, so horizontally, I'm just going to do x equals voxt. Okay, so x equals 30t, right, because 30 is our vox. And then I'm going to write the other one, y equals, right, and so since this is a cliff problem, right, you have two options. You can call the point up here, you can call that y0, and you call this y, okay? Or you can call the ground 0, and then the where it comes from y. But let's call our initial point from where we're actually projecting the ball, right, or the object. Let's call that our 0 point. So you're going to get 0, that's our y0, and then 0 times t, 0y, minus 4.9 t squared, right? So we can clean this up and just say it's negative 4.9 t squared, okay? All right, so there are our two functions, and now step three, right, is basically answer our two questions, right? Time to hit the ground and then the range. Okay, so to find the time to hit the ground, I'm going to use my y, my vertical side, because I don't know enough in the x direction, right? Because I don't know this t and I don't know this x. All right, x is my answer to part B, and t is my answer to part A. But here in the y direction, I do know y, right? And I don't know t, so that's what I'm going to solve for. T equals the square root of y divided by negative 4.9. Now, when you do this problem, when you do this equation, you do have to be careful because your final position, right, is below, right? It's in the negative direction where we started from. So when we plug it back into the equation, we need to make sure we plug in a negative number. Okay, the other reason is if I don't, I'm doing a negative divided by a negative. Okay, so we got the square root of 50 divided by 4.9. So it's going to be, turn the calculator on, square root of 50 divided by 4.9. Right, so it's basically the square root of 10. So it's going to be 3.19 seconds. Okay, and now remember, t is the only variable that can cross the barrier. So now I can plug in my t. So I'm going to go 30 times 3.19, right? And I get an x of 30 times 3.19, and it gives me a value of 95.7 meters. So there's part B, and then here is part A. Okay? Now, the next example, okay, so we have an object rolling from the top of a hill with 20 meters per second. Takes 4 seconds to hit the floor. Okay, so basically it's coming off the hill, right? So it started up here, rolled down off the hill. Okay, we know that it takes 4 seconds to go down, right, to take our path. Okay, we know that it's coming off horizontally at 20 meters per second. And we're asked to find how far out did it travel, and then how far down, how tall is the cliff or the hill, okay? So again, just follow our steps. Step one, break up our initial velocity vector, right? Great, good thing again, it's only a horizontally launched problem, so we're going to 20 meters per second in the x, 0 meters per second in the y, okay? Write our position functions. All right, so x equals 20t. Again, we're going to call this point our 0. So y 0 is going to be 0. So we're going to get that same kind of look. The great thing about when you're launching horizontally, okay, this will be your equation in the y direction always, okay, because always call the 0 point at the top of the hill, and then you can go from there, okay? Now, we do know time, right? So the great thing is, because we know time, we can plug it in, right? We don't have to do anything to solve for time. It gives it to us. So we can find the range. It's going to be 20 times 4, right? So x will be 80 meters. So that is our answer to part A. And then the answer to part B, negative 4.9 times 4 squared. Now, when you report a height, you don't have to put the negative sign, right? Because that's where it's falling from. And so this will be 78.4 meters. Okay? So we have our answer to part B. We have a x, or a range of 80 meters and a height for the hill of 78.4 meters. Okay. Now let's do this last problem. Chose this problem because of the situation that is happening, right? So an airplane is moving horizontally at 500 meters above the ground with an unknown speed. A crate is released from the plane and travels, a horizontal distance of 4,000 meters before striking the ground. Find A, the plane's horizontal speed, and B, the crate's final velocity, which is its magnitude and direction, okay? Now, when you get these problems, all right, remember, projectiles will assume the speed of the vehicle, right, of the moving vehicle. So even though we don't know much about the plane, if we know how far that, or how fast that object was released or was traveling to start, we have the speed of the plane. Okay, because they assume the velocity of their vehicles. Okay, again, start with our breaking that vector down, right? So VOX we don't know, VOY we know is 0, right? And then we go into our H and our V. Okay, we do know that it lands 4,000 meters away. Okay, and we know that it's going to fall 500 meters, right? So that kind of rounds out what we know. So we're going to say x equals VOXT, okay? Because we don't know VOX, so I'm not going to put anything in there yet. And then for y, again, it's going to be this negative 4.9 t squared, okay? And then again, from the vertical side, I'm going to solve for t, which ends up being square root of y over negative 4.9. And you say t equals the square root of negative 500, because again, it's going to fall 500 meters, okay, because the plane is 500 meters off the ground. So the square root of negative 500 divided by negative 4.9, or we just say in our calculator, we can just disregard the negatives. And so that's going to be 10.1 seconds, okay? So this t now goes here, and we say 4,000. Actually, let's solve it first, right? Get in the habit of solving it first. Okay, so we're going to say our unknown is VOX, so VOX equals x over t. And so VOX will equal 4,000 divided by 10.1, and this will give us the velocity of the plane, because this will be how fast the projectile was traveling to go 4,000 meters. So that's going to be 396 meters per second. Okay, so there's our answer to part A. Okay, part B now. is to find the velocity, right, as it strikes the ground. But we know Vx, the final velocity at the ground, is just going to be the velocity that it started with, right? When we talked about the equations, that's how we just solved that. And then Vy is going to be Voy minus 9.8t, which the great thing is, again, because that's just going to be 0. So our y component is going to be negative 9.8 times t, which is negative 9.8 times 10.1, which equals approximately 98. But let's figure it out since we are using 10.1. So it's going to be 98, really 99.0. Okay, so it's going to be 99.0 meters per second. Okay, so now how do we find the magnitude? Well, we're going to do the square root of 396 squared plus 99 squared. Okay, this will give us the magnitude. So the square root of 396 squared plus 99 squared, and this will actually be negative 99. And that's going to be 408 meters per second. And now we find the angle, right? Because this is now the direction. So you're going to do the inverse tangent of dy over vx. And so that's going to be the inverse tangent of 99.0 divided by 396. In fact, this will be a negative 99.0. And so that will be negative 14.0 degrees. So here is the magnitude, and then here is the direction. Okay, so that is launched horizontally. Okay, now the next set of videos will be focusing on when it's launched at an angle, whether it be upward or a